This is my first class for IBPS quantitative aptitude part. Uh, First, let me introduce myself. My name is Kavish, and I have qualified all the IBPS exams lately in 2015 and 2016. I scored quite well in the PO and clerk exams in 2015. In 2016, I qualified for IBPS IT officer exams. So I will be giving you coaching for quantitative aptitude part, which comes in banking exams. Not only banking exams, this part is pretty much covered in all the exams. For example, SSC or railways, quantitative aptitude is pretty much important to clear the cutoff. So to make your good grip over the subject, I will be giving you some topics and some deep information about the topics so that you can clear your basics and attempt each and every question in the exam. So let's start. First of all, let's see what are the weightage of questions and what is the mark distribution of quant part in the banking exams. So in generally, banking exams consists of 5 sections, which are general awareness and computers. We all know that general awareness and computers are do not require any calculations or as such, but the quant and reasoning part requires pretty much calculations. And seeing the latest trend, we are seeing that there has been introduced the sectional timings.
If you wish, you can turn off your video now. Yeah.
Okay, I have done.
Yeah, please go on.
So there has been a new pattern of the banking exams, which has been that every section has been allotted a time slot of 40 minutes. So 40 into 5 makes 200 minutes. So you have to attempt one section in given time. So this makes this exam more tough. So to tackle this time strategy, we have to make. So I will be telling you which topics we have to cover first, which are the hot favorite topics which come in IBPS exams, and later on we will switch to the topics which are common in every exam but they are not that frequent. So to fetch 40 marks, to fetch at least 30 or 25 out of 40 marks in quant part, you have to work quite a bit on your calculations and you have to know basic mathematics. Basically, you need to know all the mathematics you have studied up to 8th class. So this is my first class. I am going to tell you about mathematics and the number system. So let's see what are numbers. Numbers in mathematics are as important as alphabets in English. For example, we cannot write any word or any sentence without alphabets in English. Similarly, we cannot write any mathematical expression or equation without numbers. There are many numbers in mathematics, but there are many types of number also. Each number is classified into a different type. We will now discuss different type of numbers and number systems there are in mathematics which are useful for competitive exams. So let's see. First type of number is natural numbers. Natural, as we know, is derived from the word nature. So natural numbers is related to nature in a certain way. For example, a normal human being would count from 1, not from 0. So natural numbers covers all the numbers from 1 to infinity. Infinity is nothing but no end. As we know that counting has no end, so all the numbers from 1 to infinity come under natural numbers. But there is a condition we have to see: the natural number do not cover numbers like 0.6, which is a decimal number, or 1 by 3, or rational number, or they do not also cover the irrational numbers like this. So natural numbers, as derived from nature, as nature is simple, so these numbers are simple. These numbers are from 1 to infinity, 1, 2, 3, 4, 5, 6, and you can go as long as you can. These numbers are infinity. So till infinity. So we can say that natural numbers is the set of all the numbers from 1 to infinity, excluding decimal and fractions and all other types of numbers. Just simple numbers come under natural numbers. So I hope you must have understand what are natural numbers. Now let's go to another type of numbers, which are whole numbers are natural numbers, like natural numbers, or we can say same as natural numbers, but they include an additional number, which is 0. So we can write whole numbers as all the numbers from 0 to infinity, and we do not cover numbers like 0.9, 1/3, which is a rational number, 0.89878, anything. So whole numbers are all the natural numbers including 0. So I hope you must have understood the difference between natural numbers and whole numbers. Natural numbers related to nature, as we count, as we write natural numbers. Whole numbers are similar to natural numbers, but they include 0. So let's go on to the next number type. Next number system or number type we are going to discuss is integers. Now integers are all the numbers which are covered in natural numbers and negative of those numbers, including 0. So basically natural numbers, as we see, it is from 1 to infinity. For example, if we have to write first 10 natural numbers, we will write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that will be first 10 natural numbers. If we attach a negative sign to all of these numbers, the number will become -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. So these are integers. Or as we have written that integers are all the numbers which are covered in natural numbers and also negative of those numbers. So -1, -2 and all these numbers come under integers, but they are not natural, because natural numbers are only positive and whole numbers are also positive. But integers can include discrete negative values also, but they also don't cover fractions, decimals, rational numbers and irrational numbers. So integers are basically natural set of natural numbers and the complementary, or we can say negative set of those numbers including 0. Now let us see some examples of different numbers we have discussed. First, let's see some example of natural numbers. So if we have to write natural numbers which are greater than 2 and less than 8. So greater than 2, the next natural number we can see that after 2 comes 3. So greater than 2 is 3. Next 4. Next 5. Next 6. Then comes 7. We have to write natural number greater than 2 and less than 8. So these are the natural numbers we get. I hope you must have understood what are natural numbers. So let's go to the whole numbers. So whole numbers, as we know, are same as natural numbers, but they include 0. So if we have first 6 natural numbers, first 6 whole numbers, we will write 0, 1, 2, 3, 4, 5. So these are our first 6 natural numbers. Now our next part is integers. As we know, integers also include the negative part of a number, or we can say the negative numbers are also included in integers, but they also don't cover fractions, decimals, or any weird number like that. So let's discuss some examples of integers. So if I have to write two integers less than 0, any two integers less than 0. As we know that the number less than 0 will always be negative, so any two integers less than 0 can be minus 9, minus 89. These are two integers less than 0. If we had to write two integers greater than 0, then we can write 8, 88, or any two numbers you like which are greater than 0. But we should remember that the numbers should not be in decimal, or they should not be rational or irrational or fraction. So these are the first 3 number types we have discussed. Now let's discuss some more number types. Wait a second. Okay. So first 3 number types we have discussed are natural numbers, whole numbers, then integers. Now we are going to discuss rational numbers. Rational numbers. Now what are rational numbers? Rational numbers are numbers which can be written out of P upon Q.
Sir, interrupting. Sir, could you scroll up a bit, because what you are writing on your screen right now is not visible. Maybe you can remove some part of you have written on the top, or you can use a new editor so that you get a fresh.
Should I remove the upper part?
Maybe you can do that.
Okay. Wait. Is it visible?
Yeah, absolutely. Now? It's visible.
So we were discussing rational numbers. So rational numbers are numbers which can be written in the form of P upon Q, which means P is the numerator and Q is the denominator. P upon Q basically reminds us of the fraction we have discussed in school, or we have studied in schools. P upon Q, for example, 1 upon 2, 1 upon 3. These are all the rational numbers. But we were not familiar of rational numbers in our earlier years. For example, we come across rational numbers in ninth class in our school. So we might have forgot about this. So let's discuss rational numbers in detail now. Rational numbers are numbers which can be written in the form of P upon Q. Now let me ask a question. The question is, what if Q becomes 0? So we have come across the fraction P upon Q.
Yeah, it will be infinite. Yeah, infinite.
Yes, it's very good. The rational number will become infinity, which is not defined, or we can say not defined.
Yeah.
So that will not be a rational number. Okay. So rational number has one more condition, which is that Q or the denominator should not be equal to 0. Because if it becomes equal to 0, then the rational number will be not defined. So we cannot write it as a fraction. So let us dig deeper in the rational numbers system. So we have seen that it is of the form P upon Q. Let me take a number 1 upon 2. Now this is a rational number because it is in the form of P upon Q and Q is not equal to 0. So we can easily say that this is a rational number as it satisfies all the conditions of rational number we have written above. Now if there is a number 4, now there is one more question for you. If there is a number given just 4, can we write this as a rational number?
Number 4 cannot be a rational number.
Any explanation for
No, I'm sorry, sir.
Can you? Okay. So it is a rational number. Yes, we can write this as a rational number. Let us see how. It is the number given is 4. Just 4. No minus, no fraction form, nothing else. So as we know, anything divided by 1 is the number itself. That is clear, no?
Yeah.
So we can write this as 4 upon 1. We can write the number 4 as 4 upon 1, which is automatically equal to 4 only.
Correct.
So if I change 4 to 4 upon 1, it becomes a rational number. Because now P is equal to 4 and Q is equal to 1. I hope you got it.
I see. Yeah, absolutely. Thank you.
Now we have discussed 2 rational numbers. Now let's discuss some more. Now let's come to the negative parts or the negative integers. How we can write them as a fraction. For example, there is a number minus 2. Can you write this as a rational number?
Yes.
Yes, we can write it.
Yeah.
Same as above. We can write this as minus 2 upon 1.
Yeah.
Now we have discussed that what should P be and what should Q not be. Q should not be equal to 0, but we have not discussed the exact condition what P should be. P should be natural or whole or integers, what it should be. So let us discuss to qualify as rational numbers.
Okay.
condition to write the rational number is that q should not be 0 and p should be an integer. If I write 0.3 upon 10, if this is the number,
this is a fractional number,
not a rational.
not a
Yes,
rational
this is a fractional number, but this is not a rational number
Correct.
because the p or the numerator here, p is not an integer,
Correct.
because we have discussed that integers are only natural numbers and negative parts of that.
Correct.
But p here is not an integer. But we can write this number as a rational number. Can you tell me how? Is it possible?
Yeah, we can.
Okay, no problem.
Sorry.
Let me do.
Yeah.
Oh, no problem. As we know that 0.3 upon 10 can, if I shift the point in the front of 3, we
Okay.
can write it as 3 upon 100. Is it clear?
Yeah, yeah.
So now this becomes a rational number.
I see.
Now is the rational to every number there is a rational number representation.
Correct.
Is it clear?
Yeah, yeah, absolutely clear.
Okay. Now we have studied rational numbers, and I have said that every number can be represented as a rational number.
Yeah.
But this statement is not exactly true.
Yes.
It is
Correct.
not true. Can you tell me why?
Because if you have a fractional number on top, for example, the number you've written 0.89787, and if you if I divide by, I mean, how can I make it integer? Okay,
No, let me take the example you are saying.
Yeah.
0.89787. This is the number you are talking.
Yeah. Yeah. I mean, your question was.
Now
how-
let's make this as a rational number.
Okay.
Now let's try. We can shift the decimal to 5 places of,
Correct.
in the front.
Correct.
Sorry, in the back. Like this: 89787
Yeah.
upon.
Yeah. 150.
So this is a rational number.
Correct.
Okay. So I said that every number can be represented as a rational number, and I also said that my statement is not exactly true. So can you try some other explanation, or can you think of any other explanation which you can give that why this statement is not true? No.
Not at the moment. Sorry.
No. Okay. So we have discussed rational numbers only.
Hmm.
But there are one more type of numbers which are irrational numbers.
Okay.
Okay. That will explain the concept why we cannot write every number as rational numbers.
Okay.
Now, irrational numbers. The definition is just opposite of rational numbers. This is that the numbers which cannot be written in the form of
Rational number.
p upon q.
Yeah.
Okay. And here also condition is that q should not be 0.
0.
Now, what do we get from that? That numbers which cannot be written in the form of p upon q. I mean, every number can be written in the form of p upon q. For example, I have shown you various numbers. You can take all the numbers we have above. 0.6 can be written as 6 upon 10.
Correct.
But 1 upon 3 is written as such. 0.676565 can be written after shifting the decimal 6 places ahead
Yeah.
and attaching the 1 and 6 zeros in the denominator.
Yeah.
0.9 can also be written, 1 by 3 can also be written.
Correct.
I mean, every number I have discussed above can be written as a rational number
Correct.
in the form of p upon q. So which are these irrational numbers? Where have they come up from? Now let's see one such number. You must be knowing of pi. I hope you know pi.
Yeah, I know.
Do you know its value?
22 by 7?
22 by 7. This has been taught by our teacher. Right?
Yeah.
But this is not the exact value. The exact value of pi is non-extinguishable. It means that the value of pi does not end anywhere. It is a non-terminating number.
Okay.
For example, pi, as you have said, 22 by 7, or we write it as 3.1. Correct?
Yeah, correct.
Okay. But this is not the value of pi. The correct value of pi does not end. It is a non-terminating number. The numbers which end are called terminating numbers, and the numbers which do not end are called non-terminating. For example, if you take 0.6, if we take 0.6, it is just a terminating number. It terminates or it ends at 0.6. There is no any other digit after that, nothing doing. 0.6 is just the end. But if we divide 22 by 7 on our calculator, the calculator might stop at 8 digits after the decimal, but the expansion is just going on and on and on and on. So the 22 upon 7 or pi we have discussed is a never ending number. So for example, here you have said me that value of pi is 3.14. But this is just the value up to 2 decimal places. Correct?
Yeah.
So if we take the value of pi as 3.14 only, then we can write it as a rational number like this. Got it?
Yeah.
Have you got that? How 3.14 can be written as a rational number? Like this.
Is it really true? We cannot write it as a rational number, right? Because we don't know the extended.
The value you have been taught in the schools, I am saying the value that you have been taught up to 2 decimal places, 3.14.
Yeah.
We know that it is possible to write it as a rational number by dividing by 100 and shifting the decimal places.
Yeah. 314 by 100.
But as we know that the pi, value of pi never ends.
Correct.
For example, if I write 3.14 and anything gibberish after that, like this, so this is the value. It keeps on extending and extending. There is no end.
Okay.
So is it possible now to write it as a rational number? Can you think? Like shifting decimal places to 5 places ahead, 10 places ahead, 3 places ahead.
No.
Is it possible?
No, not possible because it's never ending.
Yes, it is not possible. So we can see that it cannot be written in the P upon Q form.
Correct.
Correct? So this type of number is known as irrational number.
Okay.
Now you got what are irrational numbers?
Yeah, absolutely.
Okay. So let's take one more example. 1 upon 3, the number we have written above, 1 upon 3. If you do 1 upon 3, calculation of 1 upon 3, the answer will come 0.33333.
Yeah.
This will also be a never ending. So 1 upon 3 is an irrational number because it cannot be written in the form of P upon Q.
Yeah.
Because we cannot shift the decimal any places ahead because we do not know how many digits are there. They go on till infinity.
Yeah.
They are not ending. Okay?
Yeah.
So I hope now the concept of rational and irrational number is clear.
Very much clear. Thank you.
Okay. So do me a favor. You have to solve this 1 upon 4. Can you see?
No, not really. Could you please scroll down or remove some part of the screen?
Okay. 1 minute. Can you see this number 1 upon 4? Or not?
Not yet.
Okay.
Yeah, I can
Now
see.
can you see?
Yeah, I can see.
Okay. You have to tell that whether this number is a rational number or an irrational. Just by dividing, you can come to know.
Yeah, it is 0.25, right?
Point.
0.25. So it is a rational number.
It is a rational.
Yeah.
So I hope you got the point how to identify whether a number is rational or irrational.
Yeah, very much. Yeah.
Okay. So 1 upon 4, no doubt it is written as 0.25
Yeah.
and it is a rational number. But the case was reversed. For example, when I write 1 upon 3,
Mm.
what that becomes is
It's becomes a,
0.3333. Okay.
it's
So
become
it is
irrational.
not necessary that irrational number will always be written in decimal or rational number will always be written as decimal. Okay.
Yeah.
You have to always do the expansion. You have to do the decimal expansion to find out whether the our number is rational or irrational.
Yeah.
So next numbers. I hope rational and irrational are clear to you.
Yeah, very much clear. Thank you.
Just a moment.
Sure.
Okay. Now the last number system we are going to see is the real numbers. Let me do it. Now let's come to real numbers. Real numbers are is basically what it is basically set of numbers in mathematics, including decimals, rationals, irrationals, integers, and all other numbers existing on the universe. Okay, so real numbers basically it covers all the numbers we have discussed in mathematics: negative, be it fraction, be it decimal, rational, irrational. All the numbers are example of real numbers. Is it clear?
Yeah, very much clear.
Let me ask a simple question, true false question. Now the statement I have written, is it true or is it false?
Every integer is a real number. It should be true. It is true.
Yes, it is true.
Yeah.
Why it is true? Because we know that every number is a real number. So be it integer, be it fraction, be it decimal, be it anything.
Yeah.
It is a real number for sure.
Yeah.
Okay. Let me reverse the condition. Every real number is an integer.
No, that should not be true because irrational number is also a real number.
Yes, very good. So every real number is not an integer because real number also covers fractions and decimals and all that stuff.
Yeah.
So this statement is false.
False.
Okay. You understood natural number and whole numbers?
Yeah, very much.
Okay. Can you tell me, is this statement true?
Every integer is a whole number. Yes, it is true.
Okay. It is true.
Every integer is a whole number.
Now let me remind you of whole numbers. Whole numbers are all numbers greater than 0. And so give me a sure short answer. It is
Yeah, whole number is any number which is greater than 0, but
Yes.
zero is again integer, right?
Integer.
So
Yes.
it's not true.
It is not true.
Yeah,
So this statement is
false.
false.
Yeah,
Because integer also covers
Zero.
negative numbers
and 0.
and 0. No, whole number covers all right. But negative numbers are also there in the set of integers.
Correct. Yeah.
But that number will not be covered in whole number. So this makes our statement false.
Correct.
Please try.
Every natural number is a rational number. Yes. Yes, that's true.
Yes, that is true. Because natural number covers only discrete numbers 1, 2, 3, 4, 5.
Yeah.
That we know is rational number because we can attach 1 to the denominator and make it a p upon q number.
Correct.
So this is a true. But if I remember, every rational number is a natural number.
Every rational number is a natural number. No, because natural number is not natural number is not fractional number. But
Yes, very good.
Yeah.
Every rational number is a. So this statement becomes false.
Correct.
Because rational number also cover numbers like 1 upon 2,
Yeah.
0.5, 0.6.
Yeah.
How about this?
Every irrational number is a natural number. No.
Yes. That is also
False.
false. What is this? What can be said about this?
Every real number is a natural number. Every real number. Yeah, that's true. Every real number is. Yeah. No, it's not true. It's not true. It's false.
Oh. So this is false because real number covers every number.
Every number. Yeah.
Last one. Every integer is a.
Every integer is a natural number. Oh, every integer is a.
Every integer is an irrational number.
No, false.
Okay. So, after seeing the answers, I can see that you have understood the topic.
Yes. Yeah.
Okay, now let's move to the last topic.
Yeah.
As we have studied the natural numbers, whole, rational, irrational, integers, and real numbers. Now we have come across different numbers. Now let's operations on different operations of different types on the numbers. We all know what operations can we perform on the numbers. Can you tell me what are the operations?
Yeah. Division, multiplication, Subtraction, addition.
These are the operations we have studied in our schools.
Yes.
Now we will study how to perform these operations when they occur between many numbers in one statement only. For example, if we have this statement, is the text visible?
Yeah, visible.
Oh. For example, if this is the statement, you must have seen these questions in your school textbooks or in competitive exams.
Yeah.
Okay. So what a layman would do, he would just perform this addition first, 2 plus 3, then he would because he must think that he should think that the plus is coming before multiplication. So let's do addition first and then multiply the result by 4.
Right.
So let's try to do that. 2 plus 3 comes out to be 5, and then we multiply 5 with 4. So answer comes out to be 20. Okay, this is the wrong approach, but let's try the right approach. The right approach would be first we will do multiplication. This comes out to be 14. Now you can see there are two answers to the same problem. But the second one, this one I have selected, this one is the right one. The second one I have written the answer, 14 is correct.
Yes.
Now you may ask why I have done multiplication first. So let me remind you of the board mass you have studied in schools. Have you studied board mass?
Yes.
Yes. So let's write the formula first. Can you tell me what does board mass means? What is BODMAS? What does it denote? If you can recall.
I'm sorry, I cannot recall right now.
Okay. So B stands for bracket, O stands for off, D stands for division, M stands for multiplication, A stands for addition, and S stands for subtraction. I hope it is clear.
Yeah, absolutely clear.
Okay. So now let's come to the problem we wrote about. The problem was 2 plus 3 into 4. Okay. So see my formula which I have written, bracket of division, multiplication, addition, subtraction. Okay. So we know that division and multiplication, it comes before addition and subtraction.
Yeah.
So while going from left to right, the division has higher preference than addition and subtraction, or multiplication has higher preference than addition and subtraction.
Yeah.
I hope it is clear, the preference concept.
Yeah, very much clear.
Okay. So we know that the multiplication should be given the higher priority over addition or subtraction.
Correct.
So let's come to our question. 2 plus 3 into 4 into or multiply 4. So we will first do multiply, because the board mass rule I have written tells us to do multiply first and then addition. So we can write 2 plus, as we know that 3 into 4 is 12. So let's write this. Now we have only one operator left, which is the addition. So we will do 2 plus 12, which is equal to 14. So this is our correct answer, not the 20. I hope it is clear.
Yeah, it's clear.
Okay. So please solve this one question for me. slash sign you see here is of division.
Yeah.
Okay. Please solve this.
Okay, it is 15.5 plus 21 means 36.5.
Okay, that is great. The answer is correct.
Yeah.
So what you have done first is division,
Correct.
because division has higher priority than addition.
Correct.
Okay. So let's come to a complex, not complex, but a conflicting priority question. For example, if you have 21 into now I have written 21 multiply by 3 divide by 3.
Okay.
Now what you would do after seeing the rule, you would just divide first 3 by 3, which comes out to be 1. Then you will multiply by 1. Correct? You would do this.
Yes, I will follow the Bodmer's rules where division. Okay, yeah, division is higher priority.
But there is some catch in the above rule I have told you. So let's see what the exception is there.
Okay.
You have seen bracket of division, multiplication, addition and subtraction. Okay.
Yeah.
So the division and multiplication belong to same group. Okay. Division and multiplication belong to same group. But if sign of multiplication comes earlier than division, then multiplication must be performed. Let's come to the question. 21 into 3 divide by 3. This was the question.
Right.
Now I have told that the exception is that division and multiplication belong to same group. Okay, so as we know, we have multiply and divide both. They both belong to same group. But if sign of multiplication comes earlier than division, now in the question we see that sign of multiplication comes first, then comes the sign of division. So I have written that the multiplication must be performed
Earlier.
first.
Yeah. So 63
Okay.
by 3.
So the answer will come same,
Yeah.
21.
Yeah.
But the method you have to adopt is that you have to multiply first, then you have to divide.
Right.
I hope you got the point.
Yeah, I got the point.
Okay. Please solve this one question for me then. Solve this question.
Okay, I will follow the same rules here.
Okay.
So, yeah, it's a result will ultimately be same, but I will prefer to make it more easy. I will have 14 by 20, that is 1 by 2.
Okay.
Then 196 by 2, that's 198.
98. Okay. You have firstly performed division.
Correct.
No, but I have taught you that you should perform multiplication first.
Okay.
Okay, so
Yeah.
you should perform 196 multiply 14 first,
Hmm.
and then you have to divide by 28. Because multiplication sign is coming before division, so multiplication has higher priority than division.
Yes.
Okay, you got where you were wrong.
Yeah, I'm wrong.
Okay. No need of performing calculation. Just I was asking what method would you do. Okay.
Yeah.
Now let me tell you one more rule or explain it to you with the help. Now here the statement changes to 196 minus 14 plus 28. Now what you, wait a minute, 1 second.
Sure.
Hello?
Yeah.
Sorry.
No, it's okay.
So now we have come across two symbols which are of subtraction and addition. Correct?
Yeah.
Okay. So going through Bodmar's rule, you must say that addition must be performed before subtraction.
Correct.
But like division and multiplication, addition and subtraction also belong to same group. Okay.
Yeah.
So addition and subtraction belong to same group.
Yeah.
But if sign of subtraction comes earlier than addition, then what we will do?
We'll perform subtraction first.
Yes, very good. So we will perform subtraction first. So in this question, you can see the question?
No, it's went down.
No?
No.
Oh, wait a minute.
Could you please write on top? Or
Okay. Just wait. Now you can see?
yeah.
Okay. So how will you solve this question?
So I will 196 minus 14 plus 28.
Okay. So what will you do first?
So 196 minus 14 equals to 182.
Okay.
182 plus 28. 120. Yeah, 110. Like 20.
What will be the answer?
It is 110.
110.
182 plus 28 equals to
It will be 210.
Sorry, 210.
Okay. So you got the concept of this?
Yes.
About this. Okay. So this ends our class today. We have covered the number system. Number system and Bodmar's. I hope you understood the concept of number system and Bodmar's.
Yeah, very much. It was very much explanatory.
Okay. Is there any doubt or any suggestions you would like to give?
No, I don't have any doubt actually. It's very much
Okay.
clear.
Any suggestions or any feedback?
No, not really. It was very good actually. The way you explain the
Okay.
topics and in so details, it's very much helpful to
Okay.
understand the topics